Hello, this is the fourth video out on the Network Dummy channel, and today we'll be going over VLANs. We'll be working with the same topology we were working with in the last video. Again, this is the network topology. One router, two switches, and four end devices. In this exercise, you'll be doing the VLAN configuration yourself. As you can see in the problem statement, there are three activities that you have to do to accomplish this activity. Question 1. Configure the below devices to their respective VLANs. Question 2. Configure routers on a stick. Configure 3. Ensure that PC from VLAN 10 or 20 can ping PC from VLAN 30 or 40. Like the previous exercise, you should first try to solve it yourselves, and if you can't, that's alright, I'll give you the answers right now. There are three specific steps you'll have to carry out to configure VLANs in this topology, which includes assigning end devices to be access ports in their respective VLANs, B. Assigning the link between switch and router as trunk ports, and C. Configuring native VLAN match between switches and allowing correct VLAN traffic. I will attempt to complete 1A right now. To configure end devices to be access ports in their respective VLANs, we'll have to enter interface configuration of the switches itself. First, we'll go to FA01 to configure it. Now that we're in interface configuration mode, there are only two commands that we have to put in to assign it to be an access port, which is switch port mode access, followed by switch port access VLAN 10. This manually moves the interface to VLAN 10, and now we'll do the same for VLAN 20. Now we've configured FA0/1 and FA0/3 to VLAN and VLAN 20 respectively. Now we'll do the same for VLAN 30 and VLAN 40. Now that marks the end of 1A. To verify that port FA0/2 and FA0/3 is indeed part of VLAN 30 and VLAN 40, we can use the command do show VLAN. And as you can see here, FA0/2 and FA0/3 are indeed in VLAN 30 and VLAN 40. We'll now move on to 1B. To assign the link between switch and router as trunk ports, we'll have to enter the interface configuration of switch 1 in FA0/2 and the interface of FA0/1 on switch 2. We'll first start with switch 1. Now that we're in FA0/2 in switch 1, we'll use the command switch port mode trunk. Now that that's done, we'll do the same for switch 2. That marks the end of 1B. Now I'll move on to 1C. Configuring native VLAN match between switches and allowing correct VLAN traffic. I will first accomplish part 1 of step C, which is configuring native VLAN match between switches. For that, I'll enter int FA0/2 on switch 1 again. The command for that is switch port trunk native VLAN, and we'll use 100 in this case. Now that that's done, we'll go with part 2 of step C, which is allowing the correct VLAN traffic, and the command for that is switch port trunk allowed VLAN 10, 20, 30, and 40. The reason why I include 30 and 40 is because I want VLAN 30 and 40 to pass through to VLAN and 10 and 20 later. Now I'll do the same with switch 2. Now that marks the end for 1A, B, and C. Now we'll go on with question 2. In the previous exercise, we've established that devices in separate VLANs cannot ping each other, and that is only possible when native VLAN mismatch occurs. However, with router on a stick, ROAS, devices pinging each other in separate VLANs is possible, as inter-VLAN routing can be done with some configurations on a router. I will now proceed with question 2 to prove this. To accomplish step 2, first we will have to configure a sub-interface for each VLAN, and then we'll have to give an IP address to each of these sub-interfaces. I will now attempt to do so. First we'll click on the router, we'll go to the CLI, and conft. Now I'll enter the sub-interface of int g0/0/0.1. Now that that's done, I'll use the command encapsulation .1q10, and then I'll give it an IP address 192.168.0.254, and then a subnet mask of 255.255.255.0. Now I'll do the same for VLAN 20, which is int g0/0/0.2 encapsulation .1q20 IP address 192.168.1.254 255.255.255.0 as its subnet mask. Now I'll move on to VLAN 30. Int g0/0/1.1. I've seemed to make a mistake there. It's 1.1, not 1/1. Now that's done, I'll do the same command again. Encapsulation .1q30 IP address 192.168.2.254 with a subnet mask of 255.255.255.0. And for VLAN 40, it's 2/1.2 encapsulation .1q40, and I'll assign it an IP address again. Now that that's done, we'll move on to step 3, which is ensuring that PC from VLAN 10 or 20 can ping PC from VLAN 30 or 40. Now we'll go to PC0, desktop command prompt, and we'll go ahead and ping PC2 from VLAN 30. Ping 192.168.2.2. And as you can see here, we're getting a ping reply. Now, to verify it for sure, I'll use PC1 from VLAN 20 to ping PC3 from VLAN 40. Command prompt ping 192.168.3.3. And this should work as well. And as you can see here, we're also getting a ping reply from PC3. And that's the end of the video. If you've liked this, make sure to like and subscribe, as that would massively help the channel. Thank you and have a nice day.